For anybody just joining us, they have been finishing this last page of notes from yesterday. We did not talk about decomposing, but it was in homework. So they were supposed to use their resources to learn. And we're seeing if there's at least one person per group, maybe all three, that actually figured out what decomposing is. And we'll see how they did in just about 5, 4, 3, 2, 1. Group number 2. Someone come up and show me what F is.
Bruh.
Group number 4. You're coming up to show me what G is. Pick someone.
Not in your group.
Group number 1. No. One of you was absent. Oh, group number 4. Go. Show me G.
Yep. I'm going to write something random.
Yes, that's Alec and Cassie and Sophia. How are you 5?
Okay, I'm getting up there, boys.
How did I count?
Oh, that's good.
Hold on.
3's there. They're not there.
Wait, then who are we?
Was there someone there and then we took them out? No.
Didn't somebody transfer?
I don't think the whole group transferred.
Yeah, Brandon Park transferred.
Brandon Park.
He was.
Oh yeah, he was.
So wait, what have you guys been writing down for groups? We have 1, 2, 3, 4, 5, right?
2.
Well, because on the chart we were 5.
Oh. You guys are cute. Because other classes are bigger and they have more people. So then there's a real group 3. You guys don't have it. It's an imaginary group 3. So instead of having an imaginary group 3, I just call you guys 3. Do you want to be group 4?
Not really, because I don't really want to put that. I don't know.
Well, we don't want to do group 4.
We'll take
What can
group
group
7. We'll take group 7.
I'm not going to find random group members. Okay, for the seating chart, I guess you guys can be group 4 and you guys can be group 5. But what I meant was group 5. I meant that group of kids. One of you come up and show me who G
We are
is.
in group 69.
Oh my goodness. Alec, Cassie, or Sophia, someone up to the board. Show me G.
Wait.
You don't even know
Cassie should be the answer.
I'll explain it myself.
Now group number 4, get ready to do H.
Right, Cranston Cassie.
What is this?
Is that a +2?
It's X squared.
Jesus squared.
That's not really X squared.
It's +2.
Okay, you know what?
Lopsided T.
I can't see the thingy.
There you go.
Alright, group 4, go show me H.
This is my ticket.
Oh,
This is why we should be group 69.
it's gotta be Nikki.
Yeah, Jaden.
Doesn't have to be Nikki.
Just go for it.
Okay, I'm just gonna put it right over.
Because depending on how you decompose, there could be other answers. So let's see what he does.
We don't have to give a teacher.
If you gave a teacher, I would think that's technically not clear.
Like, what if I do like a couple of
Group number 6, is anything wrong? Does it need to be changed?
Yes.
Group number 6.
We're 69.
If something needs to be changed, go up and erase it.
Alex, we're gonna make the group name.
I'm down for that. I can do 0.
Group number 6.
I don't think he'd be like. I don't think he can buy it.
I went on.
Marco, Chi, if you see something, it's okay, go up. Erase it and change it.
Do it, Chi. Do it. Chi, do it. Chi.
No, Marco, go for it. Chi's saying
No,
no.
cheese, go.
No, Chi, do it.
He's saying no, Alec, leave him alone.
She's my father.
Nope.
That's
Yeah.
incorrect.
Wait.
Can I change that?
Yeah, you can change it.
Nope. No.
That is like.
What about group 1?
It's okay, go sit. Group number 1, if there's something you want to change, go.
Okay.
He really just changed mine to X.
You can erase.
I don't think so.
Did they really change mine into mine?
Dude, he changed my whole thing. Oh, don't erase it.
It doesn't work with alphabets.
No, -2 is in FFX.
Okay, let's see if we got there as a class.
No. They changed mine.
No, what I'm saying is in the square root, it's X -2.
No, I know, but our alphabets was bad.
How do we check?
You were assuming that it's already negative.
How do we check? How we check is function notation. Can't we check whether the decomposition worked by composing it?
No.
Who goes into what? X goes into H, okay, x is in H. Alright, that's done. X goes into H. What does H of x go into?
G of X.
Okay, so hold on, let me get my green marker out. So H of x is supposed to go into G, right? And then G of H is supposed to go into F, true?
That is
And F is the outer shell.
that is
Well, we need to check. We need to check. So how do we check? Who's the outermost? Square root of. And who is he the square root of? G of H of x. True? In this context. F is square root of who? Well, of all those guys.
IG at square root. That's just because of that.
It's not just square root of x because he has a lot more in him. Now, who's G? Okay, so hold on. So G says take this.
So G is x plus 1. Not x squared.
G would be the next one, right?
Yeah.
So G is,
G is.
but of what? What's G of? Of H of x, right? So of H of x. And who's H of x?
I'm done.
Looks good to me.
Good job, Marco.
Right? Right? Now, the way that I think about it for decomposing is I peel off the shells. You can start from the inside and work outside, or you can start from the outside and work inside. But when you have a complicated function like this, you're trying to think for f, what's the outermost? And the outermost, I think a lot of us agreed on square root of x. Remember, it's just f of x. So if you took away everything else, it'd be square root of blop. Call the blop x. Now, peel off the square root. That's f, and you have to think of what's next. If you peel off, or if you imagine the square root being gone, right? F's gone. Now say who's G? I can't go to x plus 1 yet because he's inside something, right? Oh, good. H is inside. Maybe I should do H next. So F is square root. H is the inside guy. He's the x plus 1. Then I can ignore the H. I can ignore the x plus 1. And what's left? Something squared minus 2. Got him. See it? There's another way. What way do you have?
F of x equals radical x minus 2.
Actually, let's do the or over here. So what if, okay, keep building because I'll just go off of what you're doing. What's G?
And then g of x equals x squared. And h of x equals x plus 1.
You guys tell her if she's right or wrong. I'm just saying there was more than one way. How would you check it? Plug and chug. Color coding was helpful. Now that I know what it is, let me color code it real quick. So she thought that G and H. Okay. Do you guys agree? Does it work? What would be the outer shell for F of G of H of X? It'd be a square root minus 2, right? And then what gets put into the input spot? G, which is something squared. But what gets put into the G's input? And H is both. Are there tons more variations? Not really. There's not a lot more that you could do. Because H needed to go into G, and G of H needed to go into F. But do you guys kind of see how we can make a hypothesis of what's the outermost, and then maybe what's the innermost, and then fill in between? Now, I started scribbling stuff out. That's an awful way of doing it. But that was just for the purpose of trying to let you guys visualize. Because it's really complicated when you start just putting X instead of all the other crazy stuff that is a part of the function. But decomposition, we're trying to break a more complicated function down into its elemental or its smaller pieces. But yeah, both of those work. Now, we need to go grade homework, yeah? I was pretty sure that decomposition was the one thing that we would have been like, wait, what? Did we learn that? And the answer was no, we didn't. So, some of you went and looked at examples. Some of you figured it out. Some of you went and looked at examples and didn't figure it out. And some of you were just downright lazy and just said, well, she didn't cover it. Oh, well, I'll skip it. That doesn't sound like we are honors. Not to me. Hey! Accountability is good, but also do it in a gracious, loving, quiet way. Not I'm going to call you out into your whole class way. All right. Section number, what are we on, 8? Whoa, kiddos, you know how many sections are in all of chapter 1? How many sections are there? Aha. Emily. Shh. There are 10 sections. We just finished 8. Which means we are close to a test. Okay, sorry, coming back. Section 8, that's section 7. Here we go. All these composition combination thingamabobs. Number 2 is a composition. Number 10. Did you guys go too far? Some of you that, you just keep on going and going and going when maybe you should have just stopped. I shouldn't have gone any further than just adding because there is no way to put this together unless you put him over 1 and started getting common denominators, which would have been disgusting and gross. So if you did try to put them together, I doubt it was legal. I doubt it was legal. There was no way to combine like terms, so stop. There was no way to combine like terms, so stop. There was no, oh, I could have put him over 1 and made it look like a nice rational function. Should have done that. I could have put him over 1 and multiplied by the reciprocal and made it look like a nice rational function. What about D for Sophia? Yes. Why? Because this would need to distribute to both. And if you don't write parentheses, there's no distribution. Does that make sense? Now here's something else though. Some of you went too far, and right now you're like, no, I got it right. Question, can you go crossing out these x squares just because you want to? No. Are you sure? Because I just don't like them, so I'm just going to get rid of them because I don't like them. And I'm just going to...
Some of them are binomials.
Yeah. All these ones that you crossed out that had a +1 or a -1 or a -4, they were tied together. They're not just x squared anymore. It's x squared minus 4. And unless you have the exact same factor below, I cannot combine. Or x squared plus 1. This is x squared plus 0, which is different than x squared plus 1. You have to think about binomials as being married. You can't just split them apart. You can't just take away one piece and not consider the other.
Maybe not adultery.
It wouldn't be in parentheses anymore. They wouldn't be grouped anymore. Which that happens. You can distribute and then try to, break it apart and factor a different way in, but that's not this problem.
You can't just break apart a marriage.
No, she was asking a real life question. It was valid. But it wouldn't be with parentheses. So, am I allowed to do this and say, yay, he's gone? No, that's x squared plus 0, that's x squared plus 1. They're different. And I can't do that under the square root either. Oh, wait a minute though. But no, this is so pretty. Can't I make this just x minus 2? No. If you crossed out x's above and below, you're killing poor little kittens. Check out the rule, take a picture of it, and make sure you understand it. If you tried to square root this guy, you kill poor little puppies. Take a picture of that rule, make sure you understand that one. At the very bottom, it says x cannot be 2 or negative 2, right? Oh, wait a minute. Pause. Is there more domain about x cannot equal 0? Oh, I see. You guys did corrections on your summer quest recently, or not summer quest, your chapter 1 quest recently, right? Wasn't there a weird one where we had to think about a denominator and a square root all at once with domain? Remember him? There was like a square root of x in the denominator, and we had to think, x can't be 0. Wait, x also has to be greater than 0. We had to think about both. What domain problems do you see here? Yeah, x can't be 0. And that's weird, they didn't write it. And no, it actually can be 2. I can have a 0 on top, just not on bottom. But what is it not allowed to be? It's allowed to be -2, because that would be a positive, still a 0, still legal. But what's under can't be negative, right? Do you guys remember how to do that?
Yes. Yes, and you just move the square root over.
But don't square roots have plus or minuses?
Yes, the sign switches. Little,
Oh, which one does it stay the same and which one does it change? Positive stays the same because when I move the positive over, but negative when I divide it, it would flip without going through all the different terminologies. Or if you want to think about it up here, Sophia, you were saying factor, which is also good. And you could actually think of a number line, which we're going to do later on in the year in review. You could actually test on one side of 2 and on the other side of 2. Basically, all of these guys are legal, and all of these guys are legal. Those guys fail. If you were to actually test it, because as Emily said, we can't have negatives underneath there. So here's the dealio. X can't be 0, but is 0 allowed anyway from the square root? Oh. So I didn't have to state that because these from the square root don't include 0 anyway. So I'm like, okay, well, forget it. He's not even an option. So I'm just going to have my special inequalities above 2 and below -2 as my domain, and they just made it look really snazzy by saying the magnitude of the number has to be greater than or equal to 2. Regardless of the sign, I have to be beyond 2. Beyond in the negatives or beyond in the positives. But if that was kind of hard, it's totally okay. We're going to be doing some of these, what are they called? Polynomial inequalities? Something like that in chapter 2. So it's probably harder than really should be in chapter 1. Number 18, did you guys get tricked by the notation, or did you do F of and G of? Not fun? Plug it into F, plug it into G, and then combine them. This problem, you can combine. This problem, they're polynomials. I can combine the squares with any squares, the t's with any t's, the constants with any constants. I can combine. The beginning of homework, though, you couldn't combine those, which is all t squared minus 3t minus 1. Number 32, you have a few. ABC, composition of functions, f of g of x. Take g, put it into x's input, and then simplify. Take f, put it into g's input, and simplify. What? Take g and put it into g's input? Simplify? That's weird. Number 44, you're doing, or 42, sorry. Some more compositions. 44, some weird notations. Did you get tricked or did you follow the formula? Be wearing the notation, not times of. Not times of. Anybody's history class, are you having to memorize that? Yeah. Someone in your class lost their little homework. Someone in cheer who didn't have cheer homework. Cheer? Oh, they're in algebra 1. She's super organized. You guys see everything? What did you do here? Should be fine. I don't know if that's last night's homework. 52. You were decomposing. So they gave one possibility for number 52. Does someone else have another possibility? We can grade it and make sure, like how Cassie had an alternate form. This one they just did 2 pieces because there was like one outer and one inner. I would have seen that too. The outer is 4 over block squared. What's the block? 5x plus 2. And that's what I would have done too. I guess you could have done 4 over x plus 2 squared, and then you could have had 5x be your little baby block.
Why is it f of x equals 4 over x squared? Why is it x squared on the bottom?
Well, maybe you could have done another way. Did you think of just doing 4 over x?
No, I didn't think of it.
But you could have done just 4 over x, and then your next guy would have had to have had not only the 5x plus 2, but also the square.
Okay.
But what they're trying to do is basically say what's inside. They take the most obvious, and that becomes g, so just everything else is f.
Okay.
Yeah. But the other way that I just mentioned could have been, which doesn't really do a lot of good for what this is ultimately used for. No. You could have done that, just that's not super helpful because this is still very complicated. When you decompose functions, you're trying to kind of have like the simplest f possible, the simplest g possible. And this one, like, okay, it's pretty simple, but then this guy has a squared. And then this guy is like, he's not simple at all. He still has a lot of hard things. This one's like, okay, the division thing, the squared thing, and then the 5x plus 2. But all of these are right. 60, you had a word problem. Are you still doing that very we are honors thing and just skipping word problems? Or are you actually thinking through and trying to do them?
I tried that.
Where? Oh yeah, you definitely could. Oh, you definitely could. Could have been 90t squared plus 60t plus 600. You definitely could distribute that. They just didn't for whatever reason. Did you guys realize that when it said half an hour, you had to use 1/2?
Wait, they didn't because on top they simplified. They divided it all by 3.
They just factored it. I don't know why. They liked it better. I think it's because down here when they went to plug in, they didn't want to have to be multiplying by 90 and 60, and they wanted to instead just do like simpler and then multiply by 30. It's not a big deal. You didn't have to do the factoring. And then it was just as simple as you realize they were asking you to plug in t is 1/2 and then to set y equal to 1500. The nice thing is, guys, didn't the graphing calculator handbook kind of get you ready for stuff like this? It was like, okay, figure out an equation. Now then we were using like regressions for tables and all that jazz. But it was like, hey, x is, but they wouldn't say x, they would say time or years or months or whatever it was. And then they would say something like y is, but they wouldn't use y, they would use population or, I don't know what else is in that calculator too. Population, pounds, wasn't it how heavy like female children were? Pounds, population, something else. So remember, word problems, you have to think of who is the x, who is the y. After you have your equation, plug into it. But what's nasty about letter C? The quadratic formula. But wait, what did we just finish? Didn't we finish something called the HPrecalc graphing calculator handbook where we can find the zeros of any function using our graph? Did you have to use the quadratic formula?
No.
Decimal answers, they're using a calculator anyway. Why not just graph it and find the zeros? Yeah?
Big brain.
Because they got everything to one side. You could have done intersect, but remember, if you did do intersect, wouldn't you have had to have had 1500 on the window? Which is fine. You can make your y max 1500, 2000. But yeah, you could have also graphed the y equals 1500 and then looked for that, whatever it is, intersection point. That works too. Either way. But what they did is they subtracted the 1500, and then they said, hey, let's find the zeros. And strategically speaking, like just mathematically speaking, prepare you guys for calculus. That's part of my objective with honors kids. This one takes less time because you know it's around the x-axis. So all I need is y min to be something negative and something positive. I just need my x's to be long enough, and I'm just looking for that intercept. You don't have to do the quadratic formula. You just keep on like having your x's be bigger and bigger and bigger, and not need to keep on looking about y's and x's. But I get it. Did you guys get why they didn't keep it 652.5 bacteria if they made it 653? Just real life example. You wouldn't say 0.5 of a bacteria. That's awkward. basically a round figures whole number whenever they're talking about like people or bacteria or I don't know, animals or whatever. But this they left as a decimal because you can have 0.846 of an hour. I guess you can have half of a bacteria, but let's not go into that right now. Okay. Is there anything else? Like you could have half of a person, it'd just be really awkward and not very productive for counting people. All right. Zip, zip. Questions on homework, odds or evens? Anything you need to see again or anything you want some clarification on? Huh? 44? As Emily's peeking at that, anything else? 44 is a commonly missed one on tests, like a similar type problem, because people think times and not of. It's a struggle. You guys good? All right, 1.9. As we go to 1.9, check out the backboard, kiddos. When's that homework due? If it's due Friday, that means it's not due. That's nice. So what does that mean? We're taking a couple days. Maybe not a couple full days, like all of the rest of today and maybe part of tomorrow. We might start 110 tomorrow. Section 10 is the last section. If you guys need to see your calendar, I spread out your homework assignments. Thanks to those of you guys that were asking for where it was yesterday. Now I have them all scheduled to appear. But we have this one due on the 13th, I think. That's Friday. I think homework 10 is due on Monday. I think it's due on Monday if I was to open it up. Is the 17th Monday? No, 13th, 14th, 15th, 16th, 17th. Oh, it's due on Tuesday. Spoiled rotten. So you get 2 days for 1.9 and 2 days for 1.10. Although 1.10 is a word problem section, so that kind of makes sense. And then we have our test on Wednesday, I think. I think we have our test on Wednesday. Yeah. Yeah. But I have, guys, before the weekend, I have both, well, homework 10 will be starting on Friday, so that'll make sense. This one's appearing on Friday. I also have the chapter review appearing on Friday, because some of you might want to start that over the weekend. But the test is not until next Wednesday, just for you guys to have a heads up. Okay, with that, section 9. Even though we don't have to finish it today, we sure do need to start it, especially if it's a 2-dayer one. So, inverse functions. Oof. Inverse functions. This is Leon and I were talking this morning about inverse derivatives. Or derivatives of inverse functions. That's a calculus thing. Calculus does new math. Maybe I should say new math. Yes.
It's special.
It's new to you to some extent, but it's actually like old but made
Harder. More difficult.
okay.
Challenge.
For instance, calculus in some ways is all about slope and area. In some ways. But all about slope and area. How long have we been doing slope and area for? For a long time. So it's not so much that everything's new, it's just deeper. There you go. Deeper applications of basic things that you've learned. Geometry. Calculus is built on proofs, and if you were to take it from a college professor, he or she would definitely teach you with proofs, especially if you were in like an honors math program. The whole class for calculus would be proofs. But I don't teach that way because the AP test doesn't need you to know the proofs. If that makes sense. Cool.
This one has proofs.
It's not really good. I like had to guess. I like the recipe.
The recipe?
Oh my god. You have to know like the words, and I didn't really feel like memorizing the words in class that involve numbers. Oh dear. It was just too much.
And the
Professors would be
if-then equations. Those are so stupid.
that's like one of the most practical things in all of math.
What?
You should have asked Mr. Che about logic. He took logic classes in college.
Well, logic is like.
And the if then is all the logic stuff.
Did they just able to email?
Yeah, I don't think his email still works. You can go find him on Insta though. You can go DM him.
I am John Che.
You didn't follow me back.
Or he has an
Oh,
Oaks Christian staff email address that's on their website.
Oh yeah, I was like texting from my Heritage Warriors account and be like,
I'm Mr. Che, could you come back?
I am John Che.
Alright, you guys writing down, right? Remember, I don't mind talking as long as you're multitasking. Mm.
Why don't we just tell him to come back?
did Mr. Che like work? No.
Nope,
Let's
he
make
did
the
not.
school
He didn't.
duplicate.
Yeah, I was in your class.
Mr. Che doesn't hate anyone.
Mr. Che, you're the award.
I thought
winner.
He might have not thought you were the
And then he followed us out.
easiest student in the world to teach, but
Yeah.
Mr. Che hated twins.
Jaden, no. He's in grade 5, right?
What?
For
So about last year?
Yes.
Period
Yeah.
two.
Maybe Mr. Che hated Quincy.
if you guys have both these, alright,
Oh, I'm not
And,
done with
don't worry, I'm not changing the page yet. If you guys have these notes written down, can you try to find for me the inverse button on your calculator? It was not in the graphing handbook, and yet there is a button somewhere that sometimes means inverse.
Does it say inverse?
If you finish your notes on your calculator, can you find for me the inverse?
It depends on us. No. Yeah. Is it Oaks? I think it's. I'm not sure. It's $1.
No, he's not.
If anybody has Laurel's number, you can text her and be like, hey, we missed you in class in honors today. If you need anything,
Total wants to
let me know. Yeah, tell her watch the video.
Not like,
Hi, Laurel.
even if I did say something, I can't back that up.
But you can answer any questions she might have too, which would be really helpful.
No, it's
Good idea. It kind of looks like an eye, right?
and you have this one where
Anybody find the inverse button in their calculator?
How about no? Wait, this X -1 thing.
What? There's a -1 button in your calculator?
Yeah, the X -1. Right,
Hmm.
right by matrix. Giano.
Hmm.
gosh, I heard this song.
I wonder if that's it. Let's check it. Can you guys do like a number? Because we can't do variables so good from the home screen. Can we do a number to the -1?
Yes.
Is this inverse? Oh.
Yeah, you have to put in parentheses.
Is this inverse?
No, you
Hmm.
have to have a negative.
What's this button?
Like, 0.25.
Inverse.
No. What's it doing?
That's a negative square. 1 over. Oh,
It's, yeah, it's not the inverse button. It's the reciprocal button.
Bruh.
What's the reciprocal of 5 over 1? 1 over 5. What's the reciprocal of 1 over 4? 4 over 1. Oh.
I
So
don't
this
like
is
that.
the reciprocal button. Oh, that makes sense though, because don't negative exponents mean that we, flip the base either from numerator to denominator or denominator to numerator, right? Isn't that a thing with exponents, negative exponents?
Is it in bars?
But here's the struggle. If we were doing something really cool with matrices, you guys should have seen them with Mr. Che last year, right?
Matrix.
If we were doing matrices, and if you were to do second, oh, isn't that right above the -1 button? Interesting. If we were to go to matrix, and if we were to do something like matrix A, and then hit the -1 button, now hold on. Most of us don't have matrices in our calculator. We're not doing matrices this chapter, but guess what? Now it means inverse. What?
In these little parentheses.
It means reciprocal up here, but it means inverse down here. That's weird. It's programmed two different ways. In context, -1 can mean different things.
Wait, but how do you
Oh, you'd have to, well, we're not doing matrices this chapter, remember? But you would have to, oh, I did the wrong one. Second, edit. Whenever you see edit, that's always a way to put stuff in. Now, we're not doing matrices. You don't even know what an inverse matrix is or what it does or how it works. So we're not doing that right now. But I just want to show you this -1 button with numbers means reciprocals. With x's, like if you were to do it here and you were to do x -1, it doesn't mean x inverse. It literally means 1 over x. It's going to graph 1 over x. Now my zoom is weird. But it's going to graph that reciprocal function. So when it's next to an x or when it's next to a number, -1 means reciprocal. But there are times that programmers have made it. If it's next to a matrix, it will mean inverse. Or if it's next to something like, ooh, hey, you guys know there's a second sign button, right?
Yes.
What does the second sign button do? How well do we know our unit circle from last year?
Not well.
Not well.
Oh yeah, I did too.
Can you guys make sure you're in degree mode?
Circle.
Can you guys hit the mode button and go down to degrees because we're more used to those? Once again, we're not in the trig chapter. We're not trying to learn trig. But last year you did see the unit circle. Go to degrees. Sine of 30 degrees, some of you know, equals 1/2. Right?
Yes.
Sine of 30 degrees equals 1/2. Now what happens if I do second sine? What happens if I do second sine of 30 degrees? Oh, that's easy. It's the reciprocal of 1/2. This should be 2.
I failed.
Well, number 1, I'm in some trouble. And number 2, that didn't work. Okay, so maybe that doesn't mean reciprocal? Maybe that means inverse? Can I show you how the inverse button works real quick? What if I put 0.5? Sine of 30 is 0.5, and sine inverse of 0.5 is 30. Guys, when you have a -1, that means inverse, not reciprocal. It's not flipping anything. If it means inverse, it's not flipping like a reciprocal. Instead, it's going backwards. When you see -1s with numbers, it's reciprocal. Exponents of -1s are reciprocals, but when -1s are next to functions like sine or cosine or f or y, when the -1 is next to a function, not an x, not a constant, but when it's next to a function, it doesn't mean flip. It means go backwards or undo. You guys ever had to hit the undo button? Right? You're making a PowerPoint, you're doing a project, you're doing some sort of word processing. If you accidentally fall asleep and then you're just like hit, and then you have to highlight it all and delete it, or just hit the undo button like, oh, I didn't mean to. The undo button is super, super helpful, and the math is super helpful as well. I want you guys to, underneath, not the reciprocal, when next to a function, I want you to write the word undo. Inverses undo. They're not the reciprocal, they undo. Or go backwards. So then over here, the definition of an inverse. The definition of an inverse. If I was to zoom in on that. From all of our work with compositions, last section, didn't we realize if we were doing like an f of g of x that you kind of have to start on the inside? F of g of 2. Okay, plug 2 into g and then take that and plug into f. We always start on the inside. When we're doing compositions, x goes into g, g of x goes into f. If we start on the inside, then what I want you to think about is this g guy, before he's plugged into f, he's his own dude. He could be x plus 2, he could be x minus 7, he could be 3x squared plus 2x plus 1. G could be all sorts of different things. But G, who has his own identity with all of his own terms and his own operations and his own polynomials put together, or whatever else is going on, as soon as he's put into f, what does f do to G if he's an inverse? He undoes it all. He undoes all the additions, all the subtractions, all the multiplications, all the divisions, all the powers. He strips it all away. He undoes all of the operations and gets back to x. Or if G is the inverse of f, I could put in f with all of his terms and all of his operations, And if G is the inverse, he will undo it all and end up back at X. Now, technically, there is this little note in the domain of, if it's outside the domain, then we're in trouble. But algebraically, an inverse is a function that will completely undo all the stuff going on in the other function. Now, the silly shortcut way of doing this is one that you've probably seen before. How to solve for an inverse function is you switch the x and y's and solve for y. But I want you guys to add in down here. When you solve for y, it's no longer the original. If you're given y equals f of x, then you would replace the f of x with a y, switch the x and y's, and solve for y. But when you've done that, you've undone it all. It's a brand new function, and that new function needs to be called either g of x or f inverse of x. It's no longer the same y. It's not the original. If you move everything to the other side, it's a brand new function. So be careful. This was y equals. When you solve for a y, it's a new function. It's not the same. But when you switch the x and y's, what you've done is all the values that used to be the domain are now the range of this guy. And then whatever guys were in the range, well, you switched them, are now the domain. So all the x's in the original are now the y's of the inverse, and all the y's of the original are now the x's of the inverse. Just something to keep track of and something to keep in the back of our minds. Tomorrow, we'll see that sometimes this can be really, really easy. And sometimes it can get kind of sort of hard. All right, so kids, finish up. No, we're not finished anything. Unless you didn't finish homework last night. Start, maybe, section 1.9. Otherwise, get ahead in some other class and be ready to do a little bit extra homework tomorrow. Sound good? Bye, guys.